Michael.
Right. Well, thank you, everyone. So this is a slightly different type of presentation that we're covering. I don't mean it to come off as negative, but sometimes it has been. I've been accused of being extremely negative. And I guess the first slide here doesn't really help with that statement very much. But one of my favorite quotes. So there is a, insecurity in general, and the state of security is what we're trying to discuss. Normally when I give this particular discussion, it takes a full day at a minimum, and I've actually done this over 2 days and have been requested to expand it to even longer to cover all the topics. So I'm going to literally go very quickly through this, and I would encourage everyone to please, if you have questions, to come and find us and discuss it. Very happy to do it. My intention is trying to give people a bit of a landscape of what's going on. In security, the use case is what's most important. And so a lot of the comments and things that I'm going to point out here really are directed at critical infrastructure. But the question is, if we're in communications, if we're in telecom, if we're handling people's private information or more interesting business information, does it apply? So I'll leave it to each of you individually to think about how important the types of data and information that you're touching is. And so some of this, I do believe some of these would be relevant to you as we go through it. So how do we kind of get into some of this mess, if it were? So if people aren't familiar with it, there's a term, network function virtualization. I mentioned it yesterday. It is telecoms moving and trying to adopt a faster, more nimble architecture. So one of that, and the word virtualization's in there, and so everyone thinks, oh, okay, it's the same thing enterprises have been doing for years. To some degree it is, but there's also quite a few specifications around it. And so it's not just having a hypervisor, but yet it's a very systematic architecture that gets put into place. And the reason is very compelling. There's a lot of money to be saved for the telecoms by moving to software, getting away from proprietary hardware and proprietary software implementations, making things open. And open doesn't necessarily mean open source, although it could. It means that things will, APIs are published and documented, control points are documented, and so you have interoperability, which again helps avoid vendor lock-in for telecom. So there's a big market that's growing, and the financial reasons are quite compelling. But one of the things is, sometimes that people look at these numbers and they move and press forward, and they're not considering some of the security implications of what's going on. And working with the ETSI NFV security group, we're also coming up with standards and recommendations as well. And at the very end of this, there's a bunch of references. So please do take a copy of the presentation as soon as it's posted. And you can actually look at some of at documents that are designed to help mitigate a lot of things that we'll be covering. So again, security is just always cat and mouse. You're never done. There is no such thing as secure because no matter what you do, there will always be other smart, intelligent people who are going to try to break it, and generally will break it. So the other thing that comes into mind is that there are trade-offs that come into mind. Sometimes it's performance, scalability could also be impacted. But again, security, in my mind at least, has to be looked at not necessarily from a financial investment perspective, but it's a cost of doing business. If you do not have security and do not keep up on security, you will not have a business. And the reason is that someone will come and take it from you. So again, I'm trying to get people to think about security in a very different light. Again, it's use case based, right? So if it doesn't matter if the information is removed or if the systems that you're working on are damaged or compromised, then it's okay. Security isn't important. I really haven't found anyone yet that's a true statement for, but I'll make it. Virtualization is a very complex topic, far more complex than is frequently talked about. I want to kind of get under the covers here, and again, I'm going to go very quick through it. And the final comment about in general is security is not just about technology. It's also about process. So again, even there is no silver bullet. There is no one thing or 10 things that you can do to secure systems, because there's always going to be people and process around those technologies as well. So they have to be taken into account when you're coming up with your security plan or things you should be doing around security. So again, why does this in telecom get a lot of attention, or as it should? Because telecoms are considered critical infrastructure. Fortunately here in the European Union, it's by law. So, what is critical infrastructure? It's your water treatment plant, it's your nuclear, it's your power plants, your electrical grid, telecommunication systems. So when we talk about communications and some of the things we're talking about in enabling, we just had a great presentation of lots of features that are added, but if you're integrating into a telecom system, you potentially become an access point. So your security is just as important as their security. Now here in European Union, we have the general data protection rules that are coming in, and it's one of the first pieces of legislation that actually has some real teeth to it. Companies can be fined up to 4% of their global revenue. So it doesn't matter if you want to have your headquarters in some offshore tax haven, it doesn't matter anymore. If you want to do business in Europe, they can actually fine you 4% of global revenue. It will hurt if it's actually used. So, every day is something new and interesting and when it comes to security. And this one, just from yesterday, that the U.S. acknowledged that the Boeing 757 was vulnerable. This was not an insider attack. This is an external attack. So basically, a plane sitting on a tarmac, someone externally, a researcher, was able to get into the flight control systems. The results of which are all classified, of course, but I'm pretty sure that he wasn't turning the coffee pot off and on. So again, critical infrastructure. We don't, these are very serious issues. Power plants, water treatment, communication systems, and there's just a list of a few of them, and it doesn't take much to find every day that there's more problems. So I always call it, this is the simple telecom reference architecture, and how are telecoms getting into or running into difficulties, or why are the difficulties? Well, when you look at this diagram, there's lots of things up there. It's your, it's a core of a mobile network, mobile network. And again, this is a fairly simplified diagram, but what's happening is previously you have an architecture on the left where you have proprietary hardware, proprietary software, and with this NFV movement, and again, there's compelling financial reasons to do so, we're moving to commercial off-the-shelf hardware and software. If there was an HLR box or something maintaining subscriber information previously, very few people knew actually how it worked internally. Even fewer people knew what operating system was actually running on, and the interfaces were completely proprietary. Now you have, Linux, or maybe Windows. Who knows? You have, commercial servers. So when you see a critical vulnerability published, like WPA and Wi-Fi is easily broken, that came out the other day, the telcos will have these problems too. So change cycles go out the window. You can't wait 6 months to patch or update something. It's going to be very, very interesting, and we're trying to help organizations get their head around it. And so this is a lot of what I just kind of talked through, again, going quickly. The biggest thing to understand that on the slide here towards the bottom is that virtualization layer. There's a hypervisor, where yesterday, if you had a firewall and you had a system behind it, and that firewall was compromised, or a typical telco actually would have a firewall, then another firewall, then maybe an access control system, then the device. Now you have these pieces of software that are running on a hypervisor. If you can compromise the hypervisor, you compromise everything. It does not matter if your data is encrypted running in your virtual machine or your VNF, because to get to the hypervisor, it has to be decrypted. So if someone can get and compromise the hypervisor, it is a very significant breach, because they have access to everything, and there's very little that can be done about it. There are some additional pieces of hardware, but they also have some problems. And again, normally this is a very long presentation and educational session, but we'll try to cover some of them as well. So what are some of the things that go on that, in particular, so trying to get to some very specific points here. One is, years ago, the operating system vendors realized that they needed to randomize address spaces. So if people remember, about 10, 12 years ago, all the operating systems, so this is true for everyone, came up with memory randomization. And DEP, on the hardware side. So basically, you can't execute instructions out of the data space of a program. And then how a program gets loaded into memory gets randomized. The problem is, and this is one of the primary protection mechanisms, this eliminated a complete class of threats and viruses and malware when it first came out, which was excellent. The problem is it's broken in virtualization, by definition. So the concept of memory sharing, which is a key driver for the ROI, now, the recommendation is you probably really need to turn it off. So we can talk a bit more about that as well. But this is broken, whether it's Amazon, whether it's VMware, whether it's Linux, whether it's Unix, it doesn't matter. And part of it is what the hypervisor has to do. And so we'll talk about the primary issues that come with it. Timekeeping. People don't think about it very often, but especially for things like 5G that are coming online, but even in today's systems, virtual machines keep lousy time. It's very difficult for a virtual machine to keep accurate time. And there's lots of techniques that get done around it, but these are issues that still have to be truly addressed. And there's no good answer. And you'll have clock manufacturers will say, we have clocks that use GPS, we're accurate, sub-nanosecond. And they're right, but getting the virtual machine to understand the actual time is the challenge. And we're starting to see it now in, just in logging. If you have a software system, called VNF, that maybe exists across many discrete virtual machines, and you're trying to analyze an event, so A happened, then B happened, then C happened, and you're looking at logs from different systems, the timings won't line up. So you're talking about things about milliseconds, microseconds, so you can't figure out what happened in what order. Right? And if you have to actually use that for legal issues, it's also a problem, because you can't prove by a timestamp that something occurred in a certain order. So this is, again, a serious issue that's out there. Again, I'll just let that, this is, and the reason is, in order to keep time, it's a very complex thing on a virtual system. So there's a couple techniques. None of them work all that well, quite frankly. So as Alan said, virtualization has been talked about as the root of this issue. It's just a lot of different technologies. It's also the architecture. Quite frankly, it's been said many times before, like the x86 architecture, not necessarily the best system to do virtualization on, and a lot of things have been added to it. So I mentioned cat and mouse. There's constantly improvements that are being made to help mitigate some of these issues, but it's a constant battle back and forth. One of the key things that's not being done, and so maybe this is a key takeaway, hopefully, for everyone in here, there's a very simple technique or a concept called a chain of trust, which is, who do you trust? We turn on a computer, right, and whether it's your laptop or a server, and it's interesting, you just trust that the computer starts, it's okay, the operating system loads, your applications start. Well, there's been technology available since the early 80s to actually do what's called attestation, which is to measure and verify that the hardware hasn't been tampered with. Remember, again, telecoms, critical infrastructure, the bad actors, it's not necessarily script kiddies going after this. It could be organized crime. It could be terrorists, and it could be nations that are trying to hack into this. And again, if you have software that's tying in or layered on top of telcos, you become an access point. Right? So you have to really think about this. So are we, on the clouds that we're using, how do you make sure that the hardware hasn't been tampered with? There are documented cases where different organizations have intercepted shipments from FedEx and UPS and DHL and inserted a different network card or done other things to it. So what's very important is getting to a core root of trust, making sure that the hardware itself hasn't been tampered with before you even start loading the operating system. And what's interesting is happens in everyone here has a Windows laptop or Windows 10 laptop. This is mandated in Windows laptops. It's the trusted boot. But yet our servers don't use this. TPM chips are cheap. This isn't that's going to add millions of dollars. So the older TPMs can be had for less than $1. The newer TPMs, just a few dollars more. So why aren't people doing this? And part of it, they'll think about it the old way is the management of it. They'll say it's too complex, which is simply no longer true. So that was true in the early 90s. There are now techniques to make it much easier to manage them. So trusted execution technology, again, you turn the computer on, it has to go through the BIOS, make sure things are going, load the kernel, get what's called a measurement, right? So measurements would be hashes and values that are compared to, and there's a piece of hardware, again, something like a TPM, that can't be tampered with, or it's very difficult to tamper with it. So it gives you some level of assurance that what you think you've done, turn it on and loading the basics, is proper. So Intel makes a product that they've been kind enough to, they actually open sourced it. And this gives an idea where, again, you can measure, has the BIOS been tampered with, right? Has the, have additional pieces been tampered with? All the way through, has the operating system, the kernel, been modified? Right? So remember now, you're loading software, you're doing updates, you're doing packages. Who here in the room, when they download a piece of software, bothers really checking, the SHA-2 that publishers will put next to it? How do you know that the software that you're installing is actually hasn't been touched? So this is another level of taking it down to doing hardware measurement that's based on it. One of the key things that's out there is, and again for NAV, it's a very popular model of using OpenStack. All right, but OpenStack has a very interesting issue. Even when you do their version of trusted computing, and I am actually picking on OpenStack a little here, even when you do it for having a trusted host, the host, if there's something wrong with it, and its current model still has control plane access before it's denied. That's not good. So you have a system that you can say it's compromised, something's gotten wrong with it, whether the BIOS has been tampered with, maybe operating system, that hypervisor has been tampered with, and yet it's still allowed control plane access before it can get kicked off. Not necessarily a good idea. So again, the idea is that you can specify, this slide maybe should have come first, but the idea is that you have trusted workloads running on trusted hosts. Again, in the OpenStack trust model, right now, if I have a trusted workload, I can say only run this on trusted hosts. That works well. If you try to run a trusted workload on an untrusted host or a system that hasn't been verified, it won't load. But their model allows untrusted workloads to run on trusted hosts. It's the exact definition of breaking trust. So you can allow an outside external vendor's program to run on a computer that you've now said is secure and trusted. You're not supposed to be able to do that. Quite frankly, it's something that I've been picking on and talking with OpenStack for a long time to fix. And there are fixes available for it, they just don't want to do it. So a better attestation model would be that things get to verify themselves before they're even allowed access. And there is progress towards this, and hopefully in future versions, or the next version, we'll see this being implemented. So the idea is that systems are truly verified before allowed to start operating. Right? And then so at least you know the hardware and the operating system haven't been tampered with. Intel makes the cloud integrity product, which they've open sourced, and this gives an idea. This not only works just for a bare metal hypervisor, it also works with some container technologies like Docker, Kubernetes. And now you can actually do verification of the workloads, of the virtual systems, of the VNFs. So this is relatively new and goes back to what I was talking about before, where a lot of people think the old way of managing systems with using TPMs, it was very difficult. I would not want to be the person who had to administrate 1,000 servers. You'd lose your mind, right? Every time you patch something, update something, a lot of touching by hand, a lot of hands-on work had to be done. Intel has released a security server to help with this. It's open source. It's a BSD style license, so people can take it, make modifications to it, and they don't have to release it commercially. Right? So that's all. I think they made a very smart decision with that. We just need to see more people doing something with it. The whole idea about all of this is just getting to what's called a trusted execution environment. And this is a diagram that's shown in a bunch of places. It's just kind of from the time you turn a system on to the time at least the base operating system has been loaded, you know that it is at least not been tampered with. So the term T right here. One of the things on both sides, you'll see these things called confinement technologies. Is there anyone in the room who hasn't heard of SE Linux? Someone who doesn't know what it is. So SE Linux is a key technology that's built into the Linux operating system. It's called confinement. It's in the kernel, and it's designed for two reasons. One, it's security, but not necessarily against hacking, but also against, say, bad programs programs that have memory leaks. At a kernel level, it watches all the user processes and makes sure that they don't do things they're not supposed to do, like go into another program space, access a directory that they're not supposed to. And since it's done at the kernel level, ideally, when it's used and properly implemented, it's nearly impossible to defeat. But the problem is, so this is great, and this ships with all the Linuxes, been available for years, again. The problem is we need performance. So we'll look at the difference between bare metal and say, on the right there's SRIOV, and further over accelerated OVS. So there are packet acceleration technologies. A problem that's out there is vendors are releasing packet acceleration technologies that require confinement, SE Linux, to be disabled. So this is the answer here is really simple. If you're responsible for producing software, figure out a way to not have to disable SE Linux or the other variants of it that come with the other versions of Linux. Or, if you're buying or acquiring software from someone, ask them this question. Right? Do I have to turn SE Linux off? And if they say yes, push back on them, because this is a primary defense that needs, and if you're disabling it, you're already, you're kind of starting the race, missing one shoe already when it comes to security. Another area that we talk about quite a bit is, role-based access control. This is the old world, it's the way it's done. And it makes sense, a person has access to a resource. I'm an accounting manager, therefore I have access to the accounting system. Seems reasonable, except that even before this, prior to this role-based access control, there's another model out there that's sometimes now referred to as the next generation model, and it's the attribute-based access control. What's really interesting is that this predates role-based access control. Again, older technology that just wasn't implemented. So you'll see the difference is now you can give the object itself if then else. So I'm a remote user and I can go in via VPN and I have access to my company resources. But what if you say, well, over VPN I really shouldn't be accessing some sensitive system. So that's as opposed to an add-on or bolt-on of the VPN server, the VPN concentrator, using this type of access control lets the object itself, that's just a baked-in rule to the database, right? So it doesn't matter. Or if I'm marked as being on vacation, I shouldn't be accessing it anyway, right? Or at least throw an alarm or flag or get someone, why is, Michael's on vacation, why is he accessing, critical company documents, right? So right now, doing that from add-on products is very difficult. There are products that do that, but if you can actually add this intelligence into the information itself, you can have a much better time. They're doing it. So it kind of looks just like this. And again, the idea is that the object now has rules. Okay. So this is well, again, documented and defined. So the other thing that comes about, again, hypervisor. Why is it important? Why is attestation so important? There is, hopefully people have seen diagrams like this. There's ring 0, ring 1, ring 2, ring 3. One of the things that's out there, many people don't realize, is there's an entire computer underneath your computer. It's a management engine. It's now a critical function of all machines, and it cannot be disabled. Yesterday it was announced that they figured out, people have been trying to hack this thing for years, because Intel themselves won't release information about it. So they had successful compromise of it yesterday. Again, you never knows. This thing is running a full operating system. It can be, even if your computer is plugged in, if it's turned off, it still can be accessed. It's got its own memory controller, its own network controller. It can access any file that's open, and it can intercept, redirect, and send data TCP/IP, despite whatever the operating system sitting on top of its firewall says to do. It is truly a whole system underneath. I think that yesterday's revelations will finally, hopefully, force some changes. Interestingly enough, the hackers also found a way to disable it, which the NSA insists on. No one else, we cannot disable it. But so they figured out a way to disable it, and apparently, it's a government kill switch. So think about this, the government doesn't, at least in America, for sensitive areas, the government doesn't want this technology inside their servers. So why not? It's a good question, because it's really dangerous. And you would say, okay, well, this has to be sophisticated. And I know I might go 1 minute over, but I think this is worthwhile. Well, okay, so there's this, underneath computer that's out there, and, obviously it's got to be really complex. There was a critical vulnerability that existed for 7 years. Make a long story short, every business class computer that was shipped by Intel for approximately 7 to 8 years had this vulnerability where authentication was broken, meaning any user with zero authentication could access it. Surely, okay, so it took 7 years, finally got notified, and the problem is to fix it, it's a firmware, it's a microcode update to the processor. Very complex, meaning that if you're going to patch 1,000 servers, guarantees some of them are going to die when they're being updated. So, but surely this has to be really complex to go and pull this off and take advantage of this. No, it's about 7 lines of code. This is the actual code. So this is not difficult to do, and this is practical, demonstrated. And when the internet was scanned for systems that were on the internet and had this vulnerability, tens of thousands of systems were discovered. I'm willing to bet that even though this critical vulnerability was published back in April, give or take, that many of those systems are still out there and still unpatched. Right? So again, the weakest link becomes it becomes the access point to jump off and go in. And again, if you can get to that management engine, you can easily compromise the hypervisor in doing it. Talked about shared memory. Just go through this again. Again, that shared memory also causes problems because you can identify in guests. So I'm running as a guest. It's not a privilege escalation. It's not a hack. I can tell what memory is shared amongst the other guests, and then pretty trivially, I can identify what's running. I can fingerprint all of the other guests. This works, again, on all the different hypervisors. This will work on Amazon if you want to do it. It'll work on VMware. It doesn't matter. So it's just from the architecture. So again, shared memory is important because it adds to the financial side of the equation. And last thing is covert messaging. So this is very specific, but there's been found also a way to compromise and to send messages over the shared cache lines. Right? So this is really scary because if you can send a message over the cache, so researchers have actually built an SSH tunnel that is actually using the L3 cache. So they're running a whole TCP stack, they're using the cache, they're exchanging images, messages, whatever. That's scary, and that's kind of maybe for law enforcement, but what's really interesting is that same technique can be used to steal data from the cache lines from your neighbors. Things that get frequently cached, like decryption instructions. Your keys might be held in the cache, right? So now you'll be able to go and possibly steal your neighbor's keys. Again, very serious security considerations. Last slide, I'm done. So came close. There are public documents. So this, again, from the European Telecommunication Standards Institute. This is a published document, ETSI NFE Sec 12. A lot of the issues that we're just talking about, this is a guide to help address them. So it's a public document. Please take it, download it, look at it, give it to your people, and some of them may be applicable. Some of the things might be too heavy or might be not applicable for your environment, but some of them your people should be doing. Thank you. And again, this presentation will be available, and there's 2 more pages of references and documentation in it as well. So please feel free to grab it and get the documents and ask any questions you have of me and my team here. Thank you.
Excellent. Thank you so much, Michael. So while I get myself set up, if you could do the Q&A for yourself.
Sure. Are there any questions?
What's the good news? Oh, here you go.
Oh. That's on the mic. Well, the good news is that people, security is finally getting some more limelight. You're seeing more about this in mainstream news, when it's not just people in dark areas and security researchers, and no one reads about it. So there's a growing realization security is important. I still try to work with executives who still think of it as a cost benefit, right? We'll also run an actuary table on whether or not you want to invest in security. And again, I think it's being looked at the wrong way. As we're moving to an information economy, however you want to call it, as we're moving to all software, in everything that we do, everything's connected. We talked about driving, self-driving cars. We're talking about, I gave the example of the Boeing aircraft being vulnerable. That we didn't have Wi-Fi on airplanes 10 years ago, right? So as things become more connected, security just becomes more and more important. And I think the good news is that it's getting more airtime, and that it's people are more willing to have that conversation. And if we can get more security done up front, it doesn't necessarily have a huge cost impact. This isn't me standing up here saying you have to spend millions of dollars on some product to fix it. If planning went in, so anyone here doing agile development? Anyone? I know he does. So if you're doing agile development, right? Where in your storyboards is security? Where if it had just been designed securely up front, would have been much better.
Excellent. Thank you so much, Mike.